obtain moment generating function m.g.f, hence or otherwise obtain mean and variance. Proof moment generating function about origin is mxt equals to e bracket starts e raised to power tx bracket close equals to 0 integral 0 to infinity e raised to power tx f of x dx equals to 0 to infinity integral 0 to infinity e raised to power tx e raised to power minus x x raised to power m minus 1 dx upon m factorial where x is greater than 0 equals to 1 upon m factorial integral 0 to infinity e raised to power minus bracket starts 1 minus t bracket close x raised to power m minus 1 dx equals to 1 upon m factorial integral 0 to infinity e raised to power minus bracket starts 1 minus t bracket close x bracket starts 1 minus t raised to power m minus 1 into x raised to power m minus 1 dx upon 1 minus t raised to power m minus 1 equals to 1 upon m factorial integral 0 to infinity e raised to power bracket starts 1 minus t raised to power x t into x square bracket starts 1 minus t bracket close x square bracket close whole raised to power m minus 1 this and this whole term upon 1 minus t raised to power m minus 1. Let 1 minus t into x is equal to y, which implies dx is equal to dy upon 1 minus t. Therefore mxt is equal to 1 upon m factorial integral 0 to infinity e raised to power minus y raised to power m minus 1 upon 1 minus t raised to power m minus 1 dy bracket upon 1 minus t equals to 1 upon m factorial into 1 upon m factorial into 1 minus t raised to power m minus 1 into 1 minus t integral 0 to infinity e raised to power minus y raised to power minus m minus 1 y raised to m minus 1 dy equals to 1 upon m factorial bracket starts 1 minus t bracket close whole raised to power m integral 0 to infinity e raised to power minus y raised to power m minus 1 dy equals to mx t 1 upon m factorial 1 minus t raised to power m factorial, because m factorial equals to integral 0 to infinity e raised to power minus y raised to power m minus 1 dy equals to 1 upon 1 minus t raised to power m so equals to 1 minus t raised to power minus m, where modulus of t is less than 1. Thus mxt equals to bracket starts 1 minus t whole raised to power minus m, where modulus of t is less than 1. Second property, the cumulant of generating function kxt is given by kxt is equal to log of mxt, so equals to minus m log 1 minus t, because mxt is equal to 1 minus t raised to power minus m equals to minus m square bracket starts minus bracket starts t plus t square upon 2 plus t cube upon 3 plus t raised to power 4 upon 4 plus so on bracket close square bracket close, because log of 1 minus x is equal to minus bracket starts x plus x square upon 2 x cube upon 3 plus so on bracket close square bracket close. equals to m bracket starts t plus t square upon 2 t plus t cube upon 3 plus t 4.4 plus so on bracket close equals to m t raised to t upon 1 factorial plus t square upon 2 factorial plus 2t cube upon 3 factorial plus 6t 4.4 factorial plus so on bracket close. Therefore mean k1 equal to the coefficient of t is kxt is given by m, variance mu2 k2, coefficients of t square upon 2 in kxt is m, therefore x is congruent to gamma m. Mean and variance equals to m, mu3 k3, coefficients of t square upon 3 factorial in kxt is 2m, k4 the coefficients of t raised to 4.4 factorial, the kxt is 6 into m, so mu4 equal to k4 plus 3k 2 square equals to 6m plus 3m square. Coefficients of skewness beta 1 is equal to mu 3 square upon mu 2 cube equals to 2m whole square upon m cube equals to 4 upon m, or gamma 1 equal to 2 upon under root m is greater than 0. Coefficients of kurtosis equals to beta 2 mu 4 upon mu 2 whole raised to power 2 equals to 6m plus 3m square upon m square equals to 3 plus 6 upon m, or gamma 2 is equal to beta 2 minus 3 equals to 3 plus 6m minus 3 equals to 6 upon m greater than 0. Hence mean and variance equals to m, and coefficients of skewness gamma 1 equal to 2 upon under root greater than 0, and coefficient of kurtosis gamma 2 6 upon m is greater than 0.